Okay, you're given a line, the equation of a line right here, 7x plus y equals minus 2 equals 0. We want to find the point on that line that's closest to the point -6, -6. You don't need calculus to actually do this problem. I'll quickly go through that. Here's the line, y equals -7x plus 2. Here's the point -6, -6. The shortest distance from a point to a line is along the perpendicular. So if we could find the equation of this green line and then find the point of intersection of the two lines, we'd have the point closest. And that's pretty easy to do. The equation of the perpendicular has a slope that's the negative reciprocal of -7, so that's 1/7. And using point slope and simplifying a little, or isolating y, gives us this equation. And we can solve that system using the substitution method. These y values have to be equal for the point of intersection. So here's what that shows. And if I multiply every term by 7 to clear the equation of this fraction, this is what I get. 50x equals 50, x equals 1. If x is 1, y is -5. So that's the point on the line closest to -6, -6. Now, if you want to use calculus, then instead of saying this, well, the idea is that any point on this red line, if the x coordinate is x, the y coordinate is -7x plus 2. And if we use the distance formula to find the distance between those 2 points, that would be true of any point on this red line. This is the distance between those 2 points, where again, this is x and -7x plus 2. So there it is with a rational exponent. If I want to find the derivative and set it equal to 0, I'm finding the critical numbers that will either minimize or maximize this distance. So power rule, move the 1/2 down front, reduce the exponent by 1, multiply by the derivative of the inside. The derivative of x plus 6, the quantity squared, is 2 times x plus 6. The derivative of this term is put the 2 down front, -6x plus 8, reduce the exponent by 1, multiply by the derivative of the inside, chain rule, so -7. Notice that I have a 2 in the denominator here. This radical moves to the denominator. So I can cancel this 2 into these 2's. And then the first derivative only equals 0 when the numerator equals 0, which is this expression right here. So x plus 6, distribute the -7, 49x minus 56. 50x equals 50, x equals 1. Same result using calculus. Now, how do you show that that's a minimum distance? Well, you have to use either the second derivative test or the first derivative test. So I'm not going to do it, but D prime actually in D. So the one critical number is 1. We could pick a test number in the interval from to the left of 1 and a test number to the right of 1. We'll find maybe that to the left of 1, the first derivative is negative, so the original function is decreasing. To the right of 1, the first derivative is positive, increasing. That will show that this value generates a minimum. Okay, and of course you can put 1 in for x to solve for y. There you go. Hope that helped. If you have any questions, go ahead and post a comment.